Among these ruins, archaeologists found in the 18th century the villa of the father-in-law of Julius Caesar. In it, they found a library with at least 1,800 ancient scrolls with texts in Greek and Latin.
Mysteries and a long-time history have just been read/decoded by artificial intelligence. What a fascinating breakthrough. However, this tremendous advancement might be the doom of humanity too. What if AI unfolds something the world did not expect to discover? Worse, something that is threatening to humankind. Can AI read the past? Throughout human history, languages have been born, evolved, and in many cases, lost to time. These lost languages, whether spoken or written, hold vast amounts of cultural, historical, and scientific knowledge. Decoding them has long been the pursuit of linguists, historians, and archaeologists. Yet many ancient scripts remain undeciphered, such as Linear A from Minoan civilization, the Proto-Elamite script of ancient Iran, and the enigmatic symbols of the Indus Valley civilization. With the rapid advancement of artificial intelligence, AI, researchers are now turning to machines in the hope of solving these enduring mysteries. But can AI truly decode ancient languages? While we are still in the early stages, the evidence suggests that AI is emerging as a powerful ally, if not yet a complete solution, in the effort to unlock these lost voices of the past. Artificial intelligence, particularly in the form of machine learning and neural networks, excels at pattern recognition. This capability is crucial when working with ancient texts, where traditional tools are often insufficient due to incomplete data, unknown grammar rules, or scripts that are unlike anything in modern languages. A major breakthrough came in 2019 when researchers from MIT's Computer Science and Artificial Intelligence Laboratory, CSAIL, developed an AI system that could identify relationships between ancient and modern languages, using techniques such as unsupervised machine translation, where the system learns without needing aligned examples like bilingual texts. The AI was able to make surprisingly accurate associations between ancient words and their modern equivalents. One notable advantage of AI in this field is its ability to process and analyze massive amounts of data. Human researchers can spend decades trying to find patterns or meanings in inscriptions, but AI can evaluate thousands of symbols or words in seconds, testing hundreds of hypotheses simultaneously. For example, in efforts to decipher the Linear B script, a syllabic script used for writing Mycenaean Greek, AI models have helped re-evaluate earlier interpretations and even suggested alternative translations. While Linear B had already been mostly deciphered by Michael Ventris in the 50s, AI has added nuance to its understanding, showing how digital tools can enhance even well-established research. However, AI is not without its limitations. One of the biggest challenges lies in the nature of the surviving material. Many ancient languages have left behind only fragmentary texts on broken tablets, weather-worn stone, or damaged manuscripts. Often, the amount of data available is too small for traditional machine learning models, which rely on large datasets to be effective. Furthermore, many ancient languages are isolates, meaning they have no known relatives. Without any linguistic relatives to compare them to, AI systems have little to anchor their guesses. This was not a problem with languages like Latin or Old Greek, which evolved into modern languages and share common roots. For truly extinct, isolated languages, AI's task becomes exponentially more difficult. The absence of bilingual or multilingual reference texts, such as the famous Rosetta Stone, which helped scholars decode Egyptian hieroglyphs, is another major obstacle. These linguistic bridges are vital for grounding translations and understanding symbols in context. In many cases, these ancient texts exist in a vacuum, devoid of parallel translations or even known topics. Without clear cultural or situational references, it's hard for AI to assign meaning to words or phrases. While AI can suggest patterns, such as which words might be verbs or nouns, it struggles to infer meaning without a foundation of human knowledge. Despite these challenges, AI has already proven to be an invaluable tool in linguistic research. For example, Google's DeepMind and other AI groups have explored using reinforcement learning to simulate how languages evolve over time, potentially retracing linguistic roots back to their origins. Some researchers have even used computer vision, a branch of AI that focuses on image analysis, to reconstruct damaged or incomplete inscriptions by filling in missing portions based on statistical predictions. These technologies are not replacing human linguists, but rather augmenting their abilities, allowing scholars to test theories faster and with greater accuracy. A particularly promising future direction involves hybrid intelligence, where AI systems work alongside human experts. For instance, an AI might propose a set of likely meanings for a group of symbols, while historians evaluate which suggestion makes the most cultural or historical sense. This collaborative process speeds up analysis and offers richer, more reliable interpretations than either humans or machines could produce alone. In the long term, AI could help create interactive, evolving models of ancient languages where researchers can input new findings and instantly see how they impact existing translations. AI is not a magic key that will instantly unlock all ancient languages. However, it is proving to be one of the most powerful tools ever developed for this purpose. With each technological advance, AI gets better at processing ancient texts, identifying linguistic structures, and working alongside human scholars to uncover the past. While complete, independent AI-driven decipherment of an unknown language is still a goal for the future, the progress already made demonstrates enormous potential. As datasets grow, algorithms improve, and interdisciplinary collaboration deepens, AI may very well become the bridge that connects our modern world with the distant voices of ancient civilizations. Did you know it has decoded several ancient pieces of information yet? The breakthroughs. Ancient Egyptian hieroglyphs represent one of the longest used writing systems in human history, spanning thousands of years from about 3100 BCE to the 4th century CE. Hieroglyphs were a complex system that combined logograms, symbols representing words, phonetic symbols representing sounds, and determinatives indicating the meaning of a word. The breakthrough in understanding came with the discovery of the Rosetta Stone in 1799, which provided a trilingual inscription in Greek, Demotic, and Egyptian hieroglyphs, crucial for decipherment. AI's involvement in Egyptian hieroglyphs began later when computational tools were applied to help decipher the vast number of texts found in tombs, temples, and monuments. Machine learning algorithms have been trained on the large body of known hieroglyphic translations to help interpret the thousands of undetermined symbols. With neural networks and pattern recognition, AI systems can now assist researchers by automating parts of the translation process, even for less common hieroglyphs. AI also enables the efficient parsing of large corpora, assisting in the understanding of word usage across various periods and regions in ancient Egypt. Sumerian, the language of ancient Mesopotamia, is one of the oldest known written languages, dating back to the 31st century BCE. Sumerians used cuneiform script, which involved pressing a reed stylus into clay tablets. Over time, cuneiform was adapted to write other languages, most notably Akkadian, but Sumerian itself became a language of rituals and scholarship long after it ceased to be spoken. Many of Sumerian's grammatical structures remain mysterious. AI has played a key role in speeding up the process of deciphering and translating Sumerian texts. By training models on known cuneiform texts, AI systems can recognize patterns in the script and help identify meanings and grammatical structures. Machine learning algorithms can also assist in creating comprehensive Sumerian dictionaries by identifying word forms, conjugations, and prefixes/suffixes from a large database of inscriptions. AI is also used to compare cuneiform signs across different periods and regional variations, enhancing understanding of how the language evolved. Linear B is an ancient script used by the Mycenaean Greeks from around 1450 to 1200 BCE. It was deciphered by Michael Ventris in 1952, revealing it to be an early form of Greek. The script is composed of syllabic signs, and its decipherment was crucial for understanding Mycenaean Greek, which was largely unknown at the time. The breakthrough in decipherment came from the recognition of Greek words in the symbols, leading to the eventual understanding of the script. Although Linear B was deciphered before the widespread use of AI, modern machine learning methods are now applied to refine the understanding of the language. AI can process vast numbers of Linear B inscriptions and apply pattern recognition to uncover linguistic relationships between syllables and words, improving the accuracy of translations. Additionally, AI is used to identify previously unnoticed patterns in the structure of the language and help categorize the symbols more efficiently. This assists researchers in translating new inscriptions faster and more consistently. The Mayan civilization developed a sophisticated hieroglyphic writing system that combined logograms and syllabic symbols. The script was used from approximately 300 BCE to 1500 CE. For centuries, Mayan writing was misunderstood, but scholars in the 20th century began to decipher the language, primarily through the work of linguists like Yuri Knorosov. The breakthrough involved recognizing that the glyphs represented both sounds and meanings. AI has helped advance the decoding of Mayan hieroglyphs in several ways. Machine learning techniques are used to analyze a large corpus of known Mayan inscriptions, enabling researchers to rapidly compare glyphs and identify patterns. Through AI, researchers can predict meanings of glyphs based on their context, analyze variations of the same glyph in different texts, and even hypothesize the pronunciation of previously unknown words. With deep learning models, AI can assist in deciphering the Mayan language more effectively by detecting subtle variations in glyphs and their relationships to other words, ultimately speeding up the translation process. Etruscan is the language spoken by the Etruscan civilization in Italy from around 800 BCE until the rise of Rome. It is a non-Indo-European language, and much about it remains unknown. The Etruscan script is alphabetic, and many inscriptions have been found, but deciphering the language has proven difficult because of the lack of a bilingual text like the Rosetta Stone. Scholars have worked to understand its grammar and vocabulary, but key elements of the language remain elusive. AI is increasingly being used to help uncover the mysteries of Etruscan. By applying machine learning algorithms to a large database of Etruscan inscriptions, AI can identify linguistic patterns that were previously overlooked. Researchers can use AI to create probabilistic models that hypothesize potential meanings of Etruscan words based on linguistic features, such as their position in sentences or their frequency of use. Furthermore, AI helps in comparing Etruscan with known languages in the same region, such as Latin or Greek, to draw potential parallels in vocabulary and structure. The Indus Valley script, used by the ancient Harappan civilization, circa 2600 to 1900 BCE, is one of the most challenging to decipher. Over 400 symbols have been found on seals, pottery, and other artifacts, but the script remains largely enigmatic. Despite efforts from linguists and archaeologists, no definitive understanding of the script has emerged, largely due to the lack of bilingual texts or a clear understanding of the language behind the script. AI has the potential to unlock some of the mysteries of the Indus Valley script. Researchers are applying machine learning to analyze the frequency and context of symbols across different seals and artifacts. By using algorithms to detect patterns in the symbols and their combinations, AI can help identify recurring motifs or relationships between symbols, possibly revealing more about the grammar and structure of the language. However, due to the limited data, much of the work remains speculative, and the script remains one of the biggest unsolved puzzles in archaeology. Ugaritic is an ancient Semitic language spoken in the city of Ugarit, modern-day Ras Shamra, Syria, during the 14th to 12th centuries BCE. It was written in a cuneiform script, but it differed from other Mesopotamian languages like Akkadian. Ugaritic is significant for understanding the early Semitic languages and is important for the study of the Bible because of its similarities with Hebrew. AI techniques have been used to speed up the translation of Ugaritic texts by analyzing their cuneiform inscriptions, by training machine learning models on known translations and linguistic features of related Semitic languages like Hebrew and Aramaic. AI systems can suggest potential translations for ambiguous Ugaritic phrases. AI can also detect subtle patterns in Ugaritic's use of symbols, helping to refine our understanding of its grammar, syntax, and vocabulary. Proto-Sinhala is the ancestor of the modern Sinhala language, spoken predominantly in Sri Lanka. Ancient inscriptions in this language date back to around the 6th century BCE. and while much of the language's early forms are preserved, the full understanding of Proto-Sinhala's structure is still being explored. The script used for writing early Sinhala evolved from the Brahmi script, and many inscriptions have been found, although they are often incomplete. AI's application in Proto-Sinhala research focuses on the analysis of early inscriptions to track changes in the language's phonetics, grammar, and script. By comparing these early inscriptions with modern Sinhala and other languages in the region, AI systems can help determine the phonological changes over time and assist in reconstructing the linguistic features of Proto-Sinhala. This computational approach helps scholars understand the evolution of the language and its impact on the Sinhala language spoken today. Old Persian was the language of the Achaemenid Empire, used from the 6th to the 4th centuries BCE. It was written in a cuneiform script that was relatively simple compared to other cuneiform systems. The famous Behistun inscription, deciphered in the 19th century, provided a key to understanding Old Persian and its relationship to other ancient languages, such as Elamite and Akkadian. AI helps researchers process the numerous inscriptions from the Achaemenid Empire. Machine learning models can analyze these cuneiform texts, identifying common words and grammatical patterns. AI also assists in translating texts that were once difficult to read due to variations in the script. By applying deep learning techniques to large datasets of Old Persian inscriptions, AI is able to offer new insights into the language's structure, vocabulary, and syntax. The Phoenician script is one of the oldest alphabets, dating back to around 1200 BCE. It was used primarily in the ancient Mediterranean region by the Phoenician civilization. The script is important because it is the ancestor of many modern alphabets, including Greek, Latin, and Arabic. While many Phoenician inscriptions have been found, some ambiguities in their interpretation persist. AI is used to analyze and compare Phoenician inscriptions, especially by looking at contextual relationships between characters and their corresponding phonemes. AI models can help researchers distinguish between homophones, words that sound the same but are spelled differently, and analyze the script's development over time. Additionally, AI assists in translating lesser-known inscriptions by applying pattern recognition techniques, enabling researchers to refine their understanding of the Phoenician language. AI is transforming the study of ancient languages by applying computational linguistics and machine learning to uncover new insights, translate ancient scripts more quickly, and detect patterns that were once too complex to discern. While AI has not yet solved all the mysteries of ancient languages, it is undoubtedly accelerating our ability to understand these long-lost forms of communication. Still there? Here are some that still needs decoding. All that needs cracking. Linear A is an undeciphered script used by the Minoan civilization on the island of Crete between 1800 and 1450 BCE. Unlike Linear B, which was used by the Mycenaeans and deciphered in the 50s as an early form of Greek, Linear A represents a language that appears to be unrelated to any known language family. The inscriptions, found mostly on clay tablets, seem to deal with religious rituals, economic transactions, and administrative matters. However, without a bilingual text, progress has been slow. AI can play a crucial role here by analyzing the corpus of Linear A texts in conjunction with Linear B. Using machine learning algorithms, AI can identify recurring patterns, linguistic structures, and possible syntactic parallels between the two scripts. Deep learning models, particularly those trained on known script translation tasks, might simulate hypothetical meanings and validate them across large datasets. AI could also assist in reconstructing missing or damaged parts of the inscriptions by predicting likely glyph sequences based on context, thus accelerating the path toward decipherment. Rongorongo is a system of glyphs inscribed on wooden tablets discovered on Easter Island, Rapa Nui, in the 19th century. The glyphs, arranged in a unique reverse boustrophodon style, alternating direction each line, suggest a sophisticated symbolic system but whether Rongorongo constitutes a fully developed writing system is still debated. Due to colonial disruption and the loss of oral traditions, no modern Rapa Nui individuals can read it, leaving scholars with no direct means of interpretation. AI offers a modern approach to decoding Rongorongo by conducting pattern recognition across the limited surviving texts. By using neural networks and computer vision techniques, AI can digitize and categorize each glyph, recognize recurring sequences, and attempt to correlate them with known cultural or linguistic elements from Rapa Nui or other Polynesian languages. Furthermore, AI could simulate different encoding systems, e.g., syllabic, logographic, to determine the most plausible structure, providing a systematic framework for decipherment attempts. Proto-Elamite is the earliest known script of ancient Iran, dating back to around 3100 to 900 BCE. It was primarily used in administrative contexts, likely to record transactions and inventories, but the absence of a bilingual inscription and the ambiguity around the spoken language it represents have stymied efforts to interpret it. The script consists of several hundred abstract signs, many of which appear only once, complicating frequency analysis and symbol categorization. With AI, researchers can harness unsupervised learning models to detect patterns within large quantities of Proto-Elamite signs. AI systems can statistically analyze symbol placement, contextual usage, and repetition to hypothesize semantic or phonetic values. Natural language processing models, adapted from modern language translation tasks, can be trained on early Sumerian and other contemporaneous scripts to test cross-linguistic hypotheses. AI can also be employed to scan and restore damaged tablets, increasing the corpus size and refining the quality of data available for study. The Indus script, found on seals, pottery, and tablets from the ancient Indus Valley civilization, c. 2600 to 1900 BCE, is one of the most enigmatic writing systems in history. The script contains over 400 unique signs, but inscriptions are typically short, often just a few characters, making syntactic and grammatical analysis extremely difficult. With no bilingual texts and no clear link to any known language, deciphering the script has proven nearly impossible by traditional means. AI can change the game here. By analyzing spatial relationships, glyph frequencies, and symbol co-occurrences, AI algorithms can develop models of syntactic structure and suggest potential grammatical rules. Deep learning systems, especially those trained on sparse data, are well suited to working with the short inscriptions typical of the Indus script. Additionally, AI could cross-reference archaeological metadata, like object type, location, and context, with text content to identify patterns and possible meanings. This contextual approach could yield insights that are inaccessible through purely linguistic methods. The Etruscan language, spoken in ancient Italy before the rise of Rome, has been partially deciphered, especially phonetically, thanks to its alphabet's similarity to early Greek. However, many Etruscan words, grammatical structures, and idiomatic usages remain unclear. Most existing texts are funerary or religious in nature, which limits the diversity of vocabulary available for study. The lack of extensive bilingual inscriptions further hampers efforts to fully understand the language. AI can help by using semantic clustering to group unknown Etruscan words with contextually similar known words. It can also analyze patterns across Etruscan inscriptions to infer syntax rules and word relationships. Large language models, LLMs, fine-tuned on ancient Indo-European languages and known Etruscan texts, can generate plausible translations and identify linguistic structures that humans might overlook. AI can also mine archaeological databases for parallels between inscription content and material culture to contextualize ambiguous terms. The Phaistos disc is a singular artifact, a fired clay disc from Minoan Crete, dated to around 1700 BCE, bearing 241 tokens created with a set of 45 unique stamped symbols arranged in a spiral. Since no other example of the script has ever been found, and the meaning or purpose of the disc is unknown, it poses a formidable challenge to decipherment. Scholars have proposed everything from hymns to board games to calendars, but no consensus exists. AI can assist in this case by simulating various cipher systems and testing them for internal coherence. It can use image recognition to digitize the symbols with precision and apply pattern matching algorithms to compare them to linear A and other Minoan symbols. Even with a dataset limited to one object, AI can use symbolic logic and probabilistic modeling to suggest plausible readings and test them across various interpretive frameworks. Example, syllabic, ideographic, or pictographic systems. AI may also generate hypothetical parallels in other languages to spark new lines of inquiry. The Iberian script was used in the eastern and southern parts of the Iberian Peninsula from around the 5th to the 1st century BCE. The script has been mostly deciphered in terms of phonetics, but the language it represents, the Iberian language, is still poorly understood. As a non-Indo-European tongue with limited surviving vocabulary and grammar, interpreting Iberian texts remains difficult. Most inscriptions are brief and formulaic, often found on funerary or votive objects. AI can provide new methods of analysis by applying NLP techniques to the corpus of Iberian texts, attempting to uncover syntax, morphology, and semantic fields. Using comparative linguistics models, AI could test hypothetical relationships between Iberian and other ancient or modern languages. Furthermore, AI can be used to reconstruct possible etymologies and linguistic structures by clustering unknown words based on their contextual use. By integrating archaeological and geographic data, AI could also help uncover socio-cultural meanings hidden within the language. AI versus humans. In the evolving landscape of linguistic studies, particularly in the realm of ancient languages, both artificial intelligence and human scholars have played critical roles in deciphering lost or obscure scripts. While humans have been at the forefront of this endeavor for centuries, AI has emerged as a powerful tool that complements and, in some cases, surpasses human capabilities. Let's have a detailed comparison of the contributions of AI and human expertise in decoding ancient languages, emphasizing their strengths, limitations, and collaborative potential. Human scholars have long been the pioneers in the field of ancient language decoding, relying on intuition, context, and years of accumulated knowledge to decipher forgotten scripts. The most notable example is the decoding of Egyptian hieroglyphs, where scholars like Jean-François Champollion, through a combination of linguistic knowledge, historical context, and comparative analysis with known languages, cracked the code in the 19th century. Human expertise also involves not only linguistic knowledge, but also a deep understanding of history, culture, and social context, which are essential when interpreting the meanings and significance of texts. Humans possess the unique ability to adapt to the intricacies of ancient languages, considering multiple interpretations and nuances that AI systems might miss. This flexibility allows for the exploration of diverse interpretations, especially in cases where languages are incomplete or fragmented. Human scholars also excel in deciphering non-verbal communication systems, such as symbols, images, or even gestures that may accompany texts, providing a richer understanding of ancient societies. Moreover, human researchers can make informed decisions about the cultural and historical context that AI lacks, offering insights into why a certain symbol or phrase may have particular significance. However, despite their strengths, human efforts are often time-consuming and can be prone to error or subjectivity. The interpretation of ancient texts is sometimes a matter of scholarly debate, with different researchers offering conflicting translations or explanations. Additionally, human decoding processes can be limited by the availability of resources, such as incomplete inscriptions, which may not allow for a complete or accurate understanding. Artificial intelligence has revolutionized many fields, and ancient language decoding is no exception. By leveraging machine learning algorithms and natural language processing, AI systems can analyze vast amounts of linguistic data much faster than any human could. AI models can process patterns in ancient texts, compare them to modern languages, and apply statistical methods to predict meanings or identify similarities with known languages. For instance, AI has been used to analyze the Indus script, an ancient script that has remained largely undeciphered. Researchers have employed AI-based algorithms to find statistical patterns, frequency distributions, and recurring symbols that might help unlock the script's meaning. One of AI's key strengths is its ability to process large datasets. Unlike humans, AI can sift through thousands of ancient texts in a fraction of the time, identifying recurring patterns and linguistic structures. AI models also can quickly adapt to new data, making them useful in situations where new discoveries or inscriptions may provide further insight into an ancient language. Furthermore, AI's ability to work with highly fragmented or incomplete data is invaluable, as it can infer relationships and suggest potential meanings even when certain portions of the script are missing or damaged. Despite these advantages, AI is not without its limitations. AI systems are heavily reliant on the quality and quantity of data available. If the dataset is small or biased, AI models can struggle to make accurate predictions. Moreover, AI lacks the interpretive depth and contextual understanding that human scholars bring to the table. For example, while AI can detect patterns in a script, it may not be able to comprehend the cultural, historical, or societal factors that influenced the creation of that script. As a result, AI's interpretations can sometimes be superficial or fail to account for the subtleties of meaning embedded in ancient texts. Truth is, when humans work with what AI can do, the results will be promising. Do you agree? Collaboration between AI and humans. Given the strengths and weaknesses of both AI and human scholars, the most effective approach to decoding ancient languages is a collaborative one. AI can handle large datasets and identify patterns at a speed and scale that humans cannot match. However, human expertise is necessary to provide contextual understanding and interpret the results of AI analyses. This collaborative model allows AI to assist in generating hypotheses or suggesting directions for further study, while human scholars refine those insights with their deep knowledge of history, culture, and linguistic nuances. A perfect example of this collaboration is seen in the ongoing efforts to decode the Mayan script. While AI models have been used to identify patterns and correlations in the glyphs, linguists have used their expertise to refine the AI's results, ensuring that interpretations are culturally and historically accurate. In this way, AI serves as a powerful tool to accelerate the research process, while humans provide the critical interpretive framework necessary for understanding the complex nature of ancient texts. Both AI and humans offer distinct but complementary strengths in the field of ancient language decoding. Human expertise, with its deep contextual knowledge and interpretive flexibility, remains indispensable in understanding the subtleties of ancient languages. Meanwhile, AI offers an invaluable tool for processing large datasets, identifying patterns, and suggesting hypotheses that humans can further investigate. The future of ancient language decoding lies in the synergy between human scholars and AI, combining the best of both worlds to unlock the mysteries of our linguistic past. Through this collaboration, we can expect to make more rapid and accurate progress in understanding ancient civilizations and their written records. Thanks for watching the video. See you next.